Okay, good morning or good afternoon, Year 12. Today we're going to look at section 11.3 from the book, and I've posted a video of the Pete Hart video. He goes nicely through example 5. I'm not going to do that now. What I'm going to do is for section 11.3, I'm going to look at the exercise 11C. I've picked some questions that I'm going to go through with you here in detail, and then I'm going to set you a few of those questions for you to do on your own. So we're looking at page 186, 11.3, maximum and minimum problems. So, maximum and minimum problems. Now, just a quick recap of what a maximum and minimum point is. If you look at this cubic graph here, then we know that at the minimum and the maximum points on this curve, we know the gradient is 0. What I mean by that is if I was to draw a tangent at these points, the tangent would be horizontal and the gradient would be 0. So using that fact, we know if this was x and this was y, if we had a function of y equals, let's say this was, this looks like a negative cubic, so say we had, this was negative x cubed plus 3x, for example. If I was to differentiate this, okay, so I get minus 3x squared plus 3. At the values here and here, at these values we know that the gradient is 0. So the key point is the gradient at a maximum and minimum point is 0. Please write that down. Right, so have a look at the example 5, which Pete Hart goes through on the video I've attached to the PowerPoint. And I'm going to now go through question 1 on 11C. So if you have question 1 in your books, I've abbreviated it here. So question 1. You're given a particle. It says a particle P moves in a straight line such that its distance S from a fixed point O at time t is given by this formula. You're given a sketch of displacement against time, and it says determine the time at which P is moving with minimum velocity. Minimum velocity. Okay, so the first thing I want to do is get an equation for the velocity. Well, you know, to find velocity, you have to differentiate displacement with respect to time. So if I differentiate displacement with respect to time, I will get 3 times 0.4, 1.2 t squared. Bring the power down, take 1 off the power. So 0.3 times 2, 0.6 t minus 1.8. Now, that's the formula for velocity. I want to find minimum velocity. So to find minimum velocity, I want to find dv by dt and put that equal to 0. So I'm going to differentiate this again. So I'll get 2.4t, 2 times 1.2, take 1 off the power, minus 0.6. So here's my equation for acceleration, and minimum velocity is when dv by dt equals 0. And if I was to solve that, I would get t equals 0.25 seconds, and that's my answer. Find t when p is moving with minimum velocity. Okay, part B. Find s when p has minimum velocity. Okay, so we know that t equals 1/4 second, and we've got our equation for s at the beginning, which is here. So all I have to do is sub in t into this equation to get an answer for s. I'm not going to do that, but you can pause it, put that value into your calculator, and you should get, just pause the video, have a go, and you should get 4.54 meters. Any problems, please just email me and I will go through, or I can talk to you on the phone as well if anything you're not quite sure about. Right, part C of this question. Part C says find the velocity of p when it has a minimum velocity. So minimum velocity, well, we know when the minimum velocity is, but we want to find v. Well, we already know our equation from v from here. So if I just write that down again, v equals 1.2 t squared minus 0.6t minus 1.8. I know my value of t is 0.25 seconds at minimum velocity. So all I have to do is put that into here and sub in t, and I will get negative 1.88 meters per second. So that's the velocity of p when it has minimum velocity. Okay, so that's the end of that question. Right, the question I'm going to look at now, I'm going to jump, because I'm going to leave you questions 2, 3 and 4 to have a go at doing. I'm going to now look at the harder questions. So if you find question 5 in your book, please. Question 5 in your book. I've written it out here. And so we've got a particle p moving along the x-axis starting at the origin. Here's my equation to model that motion, and I've got a restriction on t. And the first question asks you to sketch displacement time graph. Right, so let's look at the equation that we've got here. And in fact, I think you could pause the video and have a go at doing that yourself, because we've done all of this work from a previous chapter in Pure. Okay, well done. You've had a good go at sketching that graph. So let's look at your solution, see if you got it right. Well, I can see I've got a cubic equation, a negative cubic equation. And I can see I can take out a factor of t squared. So if I do that. So what values will make s equal to 0? So s equals 0 when t equals 0 twice, so I've got a repeated root here, and when t equals 9/2, that's when this will equal 0. So if I think about sketching my graph now, it will go through 0 and 9/2, a repeated root here. It's a negative cubic curve, so it's going to go like this. Now let's think about what's going on my axes. Well, I've got time along here, and I've got my displacement s up here. Right, one thing is not correct about this graph. Can you see what it is? Think about this part of the graph here. What can't you have? Yep, well done. You can't have negative time. So if I was to sketch that correctly, I'll just do that in a different colour. If I was to do that again, I would just have this part of the curve. Also, I can't have negative displacement, so it can't go down here. So it goes from 0 to 9/2. And what a lot of you may have lost marks on, if this was an exam question, is including this negative time part and this negative displacement part. Okay. In fact, actually, apologies, you could have negative displacement, but the graph is telling you, is restricting it here between 0 and 4.5. Okay. Right, so justify the restriction. Well, we've just explained the restriction. We cannot have the negative time here. Okay, so it can't go back this way. Now, we could have a negative displacement, but actually if we go back to the question 5, if we read it carefully, S is actually a distance, not a displacement. Hence, my graph cannot go underneath here because I cannot have negative distance. I can have negative displacement but not distance. In this case, S stands for distance. I hope that hasn't confused you. Right, next part to this question. Part C. Right, find the maximum distance of the particle from the origin. The maximum distance of the particle from the origin. So how do I find the maximum distance? Well, if I start off with my equation for S, now what I have to do, I have to work out when ds dt equals 0. And when it equals 0, that is when I have the maximum distance. So I'm going to show you the method for this. So bring the power down, take 1 off the power, bring the power down, take 1 off the power. Let's just simplify that. The 2's cancel, and I have this as my equation. Right, if I put that equal to 0, that's when it has maximum distance. Now if I solve this quadratic, I can just take out a factor of t. In fact, I could take out 3 as well. And I'll have 3 minus, t inside the brackets. So, it has maximum distance at t equals 0 and t equals 3. Well, I said maximum distance. Well, if I go back to my graph, and it's like this, so this will be 0 and this will be 3 for my time, and this is S. I can see, sorry, apologies, this will be 3 here. And I can see that my ds by dt, remember, is equal to 0 here. So at 3, I have a maximum point. At 0, I have a minimum point. Remember when we put it equal to 0, it can be a maximum or a minimum. So t equals 0 will be a minimum point, at t equals 3 will be a maximum point. So at t equals 3, I have my maximum distance. If I put t equals 3 into this solution here, into this equation here, I will get my maximum distance. So when t equals 3, putting that in, I'll just give you the answer. You should get 13.5 meters. Putting t equals 3 into this equation here. Okay, last part to this question. I'll just give you a chance to read it. Have a go if you think you can do it yourself. Pause the video and I'll go through it with you now. Okay, part D. Find the magnitude of the acceleration of the particle at this point. So I want to find acceleration, right? I've already got ds by dt, which is equal to v. And we've already got that equation here from part C. If I differentiate v with respect to time, I will get acceleration. I want to know the magnitude of the acceleration of the particle at this point. So I don't want maximum acceleration. I'm not putting this equal to 0. All I'm going to do is put t equals 3 into this equation. So when t equals 3, I will get 9 minus 6 times 3. I will get negative 9 meters per second squared. The question does ask for the magnitude of the acceleration. So the magnitude of the acceleration, you ignore the negative sign and your answer will just be 9 meters per second squared. Okay, that was quite a complicated question. Look through it again if you think you need to. And I'm going to now have a look at the next question, the last question in this exercise. So the last question in this exercise is question 6. So I want you to pause the video, have a go at this yourself, and then I'll go through the solution with you. Okay, well done Year 12. I'm sure you've had a really good go at that. It is the last question. So let's just check your method. A train moves in a straight line along a 4-kilometre track. So the track's that long. Here's my equation for S. I've given a restriction for time t. Show that the train never reaches the end of the track, i.e. I'm going to show S never gets to 4 kilometres, which is the total distance of the track. So we want to find the maximum distance. So we want to find ds by dt. And we're going to put that equal to 0. So we differentiate our equation. We get 3.6 plus 3.52t minus 0.06 t squared. Right, I'm going to put that equal to 0 because at a maximum, or it could be a minimum, it equals 0. Now, this is quite a tricky one to try and solve. In fact, it doesn't actually factorise. We could change it to a positive quadratic by multiplying by a number, and we would get this. So whatever 180 divided by 3.6 is, if you multiply this equation by it, you might not realise that in the exam, but you can make it an easier question to factorise. It doesn't factorise, so you'd have to complete the square or use the formula. I'm not going to do that. You can look at the solutions in Solution Bank for your method there, but if you solve that, you will get this or this. Any problems on getting those answers, please let me know. But obviously time can't be negative, so this must be the time when I have ds by dt equal to 0, i.e. the maximum distance. So my last step is just to put this value into my original equation for S, and if I do that, I will get S equals 2230 meters to the nearest 3 significant figures. Or if I change that to kilometers, 2.23 kilometers. So to get that, just to recap, I put my value of t back into the original equation for S. You just check that, and that's the answer you should get. So the question, let's just go back to what the question asks. Show that the train never reaches the end of the track. Okay, well the track is 4 kilometers long. This is the maximum distance, so we could just write S max here. This is the maximum distance reached by the train, hence it never reaches the end of the track, i.e. this value is less than 4 kilometers. Okay, So we've gone through some tricky questions there, year 12, and now it's your turn. Okay, so this is what I've put on Show My Homework for you. I'd like you to do exercise 11C, questions 2, 3 and 4. Show all your method as you always do. Highlight anything you don't understand after you've corrected your work using the work solutions, and email it to me please by the set deadline. Anything you're not sure about, I will make videos and submit it to you of anything at all of these 3 questions you're not sure about. So have a good go. I'm looking forward to seeing your work, year 12. Take care, stay safe, and bye-bye.